Hi, okay, so we are going to find the surface area of a prism. Now, the one I have in my hand is a pentagonal prism, meaning as its bases, it has two parallel pentagons, and as its lateral area, this parallelograms, in this case rectangles that connect the two pentagons, we have 5 rectangles. Now, in the problem that we're about to solve, it's a hexagonal prism, but it has basically the same features except that the bases are hexagons instead of pentagons. So let's get to that. I'm going to share my screen here. Okay. So here's the problem that we're going to solve. And we know that the formula for surface area that we're going to use is the height times the perimeter plus 2 times the area of the base. So let's talk a little bit about what that means exactly. So the height and the perimeter are going to give us the lateral area. And that means that's the rectangular surfaces, in this case, 6 rectangles that connect the 2 hexagons. In this case, 6 rectangles. And then the 2b is the area of the bases. In this case, that's going to be 2 hexagons. Okay, so I want to just unpack a little bit more the HP part, the lateral area part here. So when we're working on that, the height times the perimeter. So essentially what we're finding here in the lateral area is the area of the 6 rectangles added together. So each rectangle has a height of 48 and a width of 14. And then I also know that because this is a hexagonal prism, that I've got 6 rectangles connecting those 2 hexagons, and that means I have 6 of those. So the 48 times 14 is the area of 1, but I have 6 of those. But I want you to think about this a little bit differently. What if instead of thinking about this being the area of 1, we thought about this right here, 14 times 6, being the perimeter, and this being the height. And that will hopefully make more sense to you why we multiply the height times the perimeter. It's just a quicker way to get that lateral area. So when I multiply 48 times 14 times 6, and I'm just using my calculator here, I get 4,032. So my lateral area, the HP part, is 4,032. Okay, so now I can concentrate on my 2 bases. So in this case, I've got 2 hexagons. So I'm going to find the area of 1 hexagon and then just double it. So let me go to my blue. So I know that for my hexagon, my base is going to be 1/2 apothem times perimeter. And lucky for me, all that information is given, so I don't have to do any special right triangle or 30/60 or trig to find it. So the apothem is 7√3, and the perimeter is 14 times 6. I'll just put it in there like that. And I borrowed that actually from right here. We already figured out that the perimeter was 14 times 6 there. So when I multiply all this together, and by the way, I have 2 bases. So if I change this to 2 bases, that means I'm going to multiply all of this by 2. and the 2 and the 1/2 will cancel. So to get the total area of both my bases, I'm going to multiply the perimeter, which is 14 times 6. And I'm going to multiply that times 7. I'm going to leave this exact for now. And I'm going to get 588 root 3. So now when I come back up to this and I put all of this together, my HP was 4032 plus the area of my 2 bases was 588 root 3. And then when I add that together, and I'll go ahead and get a decimal value, I'm going to have 588. And I'm just going over here to my calculator, times root 3 plus 4032, and I get 5,050.45. And I'm in inches, and this is surface area, so it's not a volume, it's still an area even though we're dealing with a 3-dimensional figure. So that's going to be inches squared.